Okay. Okay, let's get back to this simple sliding puzzle game. So what did we do last time / last night? I think we came up with like very simple data structure and movement for the sliding puzzle, where A, W, S, D keys represented kind of movement of these tiles. Great. So now today we want to spawn a window and start actually putting some graphics on this thing. There's a couple of zgamedev libraries that at some stage were working. Given that version 14 is coming really soon, it may be a bit up in the air, but we'll explore these and give them a go. So I think the ones we want are GFLW, or rather GFLW. And if we're going to be porting this to WebGL, we can do this in OpenGL too. Let's see if the getting started here tells us kind of what to do. Great, this is a really simple build file and example. See zgame examples for more complete usage. I think this should be enough to get us started. And then yeah, this is very useful too. We're going to have to add zglfw as a dependency though. But this will be okay. So like there's two ways to deal with this dependency. One is to just download the entire source, the entire zip file included in our project, like we have done for like the butterfly app and the Sudoku. Another option is to start working with the URLs in the build.zig.zon files. I kind of like the idea of just having all the code in one place. This said, this could be a good opportunity to start learning how to do that. We might do that later down the line, but for the moment, I kind of want to get stuff up and running, and then maybe once the project's stable, we'll then transition it to something else. But for the moment, we can do this. Okay, this is MIT license, which is the same as our project, so there shouldn't be any issue with just the concluding all of this. There's no official releases here, so I guess we can just just download this and start working with it. Okay. Okay, so let's make a new file called like general dependencies. And then we'll do zglfw. And then should zoom in on this. Copy that to here. And then we'll want to let's try getting this working, and then we'll do the same for the zgl, the other one. So the question is, should we like copy all of this stuff over? Let's make a dependency folder, and then within this we can do zglfw, and then we can just copy some select stuff over. Let's just copy all of this. I don't know what the zig version file is. Have I ever seen one of these before? Okay, it's just... Oh, okay, we might need a new version, a dev compiler in order to compile this. I guess we can cross that bridge when we come to it. But otherwise, we'll move this stuff across. Okay. And now we'll want to call this from our main. Well, we want to create a build file and then add that to it. Okay, so what is it saying? Saying added as a dependency. Weirdly, nothing's being specified here. Then add it as a module. Provided we're not doing in script and like that. I mean, we want to avoid using. We want to be using the Zig's custom WASM backend, so not in scripting. And then, yeah, a simple example of this. Okay, let's just add all of this. So build.zig. Try and have this here. For the executable here, let's create a different file called glfw test.zig, in which we'll add in all of this stuff. And then we'll need to create an executable to call this. I'm forgetting the field, so we'll look at whatever the build file we did for the butterfly app was. So what we need: the name, the root source file, and the target. glfw test. But if we're adding a dependency here, we're going to need a build.zig.zon file in which to point out where the dependency is. I guess there's not an example here, but we can do. We can see an example of what that should be just from the git init. I mean zig init. Do we already have one here? No. Let's do zig init, and then right, it has the sample build.zigzon file there. Temp zig init build.zig.zon. No highlighting, which is maybe an issue. Okay, let's just copy all of this over and then we'll delete it as necessary. Sliding puzzle build.zig.zon. Oops. Save that as one. That is one. Okay. Zif default username by packages on this one. So we can just call this sliding puzzle. Semantic version. It's version 1, which is optional. Oh, here is where we might need to increase the Zig version up to a 14 dev build. Each dependency must provide either URL hash or path. Okay, yeah, we know all that. Dependency. Use zigfetch save URL for a command line interface. Okay, maybe later. Okay, I think for example here, this is where we want to name this zglfw. I guess we're not doing the URL. And therefore we're not doing the hash, but the path we want. Why is this being indented weirdly? So the path here, we specify this as being in depth glfw. And this is set to true, a package is not needed. Okay. And then finally, whatever the stuff we want to save this as. Okay. Let's do this later. Okay. Okay. So we've got that in there. We've don't need this one in the init anymore. I don't think we need the butterfly quiz build one. And then we had GFW test. Okay, let's try and compile this and see if this glfw is working. Zig build is what we want. Oh, no, we don't want we don't want to build the init one. We want to build the sliding puzzle version. Fetch packages, system SDK. Why is this taking so long? Do I have to launch the resource monitor? Okay. Use of undeclared identifier standard. Really? Like, we just copied this verbatim, didn't we? Okay, so maybe this is like the new version we need. What's the current Zig dev we have? 564. We can try. No, it still doesn't like it. Yeah, we need something a lot larger than the 500s. Let's just download the new version of Zig. Okay, so let's see. We currently have this one. So we can just erase it. Where's download? Yeah, this is 3000, this will be fine. "20 minutes left, no." Okay, so this is slightly annoying that we can't yet test this. I guess in the meantime we can start thinking about what this tile should be. Do some image shopping. I'm thinking a really nice version would just be like an image of the Earth, like the famous blue marble photo from NASA. So if we go to the Wikimedia Commons and do like blue marble, it should be on here. Yeah. And one of the most famous photographs of all time. I think this is. And one of the most important of all time as well. We can get a copy of this. Oh, it's like the most valued in the category. Since this is a game and on the web, it's not going to be larger than this size. We might even want it to be smaller. Yeah, we'll do this. We want to go to, where's the sliding puzzle? The Earth scene from Apollo 17. No, the title of this is the blue marble. And of course, let's just trace the online provenance of this. Photo link.txt. I thought I said copy this. Okay. How's the Zig download going? No. Why is it so slow? In either case, we can let's make a directory called assets. Move the photo. Move the photo into it. And now we want to just convert it, JPEG, super complicated image format. Let's transform it into the QOI format, and then we can actually parse the image using our own custom QOI parser. Can I do LSAR? And okay, wow, that is significantly larger image. Not exactly compressed, but that's okay. It's still like a meg. Then what? Actually, I'm really surprised that the image format is 10 times as larger. Usually it was only, when we were dealing with the PNGs, it was the compression wasn't that bad. It was like 10% or 20% larger, not 1,000% larger. This strikes me as odd. Anyway. Oh gosh. How am I meant to build this when it's taking so long to download? Maybe there's some other parts of the program we can compute now. So let's see. Yeah, what are some things we will need to do generally? And okay, we're going to want to draw a bunch of triangles. We're going to want to draw a grid. We can at least just start coding up what this stuff will be, even if we won't be able to visualize it for quite a while. Let's just see. How long? When should we check in? It seems to get larger. How is this possible? Like, I know there's tools that exist for people just to like immediately download Zig stuff, but I don't have any experience with them. Is it an internet speed issue? Maybe it is. These numbers are not good. These numbers are pretty bad. We'll push on with the render. So, alright, so let's see. So we're going to want to like, the grid is simply not drawing like 15 squares. There's other stuff we need to add, like borders, possibly some like gaps between the tiles. All of these things are going to affect the geometry. Let's just do some sketches and figure out the geometry in our heads before we code it. We don't want to be coding an experiment. So yeah, let's do like come on. Of course there's a new version of GIMP available, and it's okay. We don't need to download it immediately. Or not like solar winds or whatever. That was such a disaster from last year. Such technical incompetence. So let's do. Is it like P for pencil? Or brush? Okay. Great, this is working. Okay. So with this grid, let's say we're doing like the simplest non-trivial grid case, which is the 2x2. What are we going to want to do with this? So we're going to want a border. And I think, okay, let's cancel all of this. So let's say these are the tiles. We don't want the tiles overlapping with any kind of space there. I think we're going to want some kind of gap. Exactly what the geometry of this looks like is going to depend on a bunch of art styles. If we wanted to simulate some kind of shadow, we'd need to draw some different kind of geometries. I think for the moment we may be able to get away with another idea that's coming to mind is to like have the tiles on like a pre-existing grid, and then the tiles like go on top of them and then slide around. This way we could then have some like dedicated borders to demarcate all of these things. As the tiles are moving, it will be clear that like they're moving just not only because the part of the tile is moving, but they'd be moving over these kind of background borders. And then this way we could probably layer the tiles to just like fit exactly in between each of these. Another option would be to check out some existing, like, to see what some other artists have done. Sliding tile puzzle, and see if there's any we want to be inspired by or just wholeheartedly copy. Okay, so for some you just have like a uniform texture in the background. There's no gaps between these ones, but they do have this curvy geometry. Okay, here's like a realistic one. These have extra geometries in them. But yeah, you know, we definitely get these kind of gaps. Really tiny. And what's this one doing? There is this extra shadow over here as well. Yeah, how do we want to implement this? What do we want the design of this to be? Why don't we go with one of the simplest things first? Like not like only tiles, but so we'll have this like this 2x2 grid. Then we want to have like a pixel of space around each tile in some sense. So let's call this like, is there a different color? This one. Any color will do. We'll call this gap like epsilon. And then we also want then we just want like no, I selected black, did I not? Oh, come on, why am I? I don't care about the quality of this drawing. It's just to like help think it out. And then this one would be like a beta. And then I think we kind of want like all of these other gaps are epsilon. So this larger border is not going to really affect the calculations if we base everything on like there's one other value we need to take care of, which is just the side length. And everything else will be determined by this. So I think this will be enough. We may just like set okay, there's going to be a bunch of colors to determine. Again, we can do those later. But just so we pre-think it, we've got this border color for the A, then we've got this like background space color, which will be some shade very close to black. We're going to need to annotate this diagram more. I don't think we only want the texture for the tile. We're going to want to add a border around each of the tiles themselves. Okay, so we're going to need to add in even more. Come on, I don't... Switch the colors, please. Super thin border, but that will... Wait, I feel like this is... Okay, admittedly, I like hardly use GIMP at all, but I feel like there's a flaw that you don't just have like a list of the previous running colors in a row that you can just pick and switch. Like maybe it feels like there's unnecessary clicks. So then there's this width here as well that's going to be, well, if we have like alpha, this epsilon, I guess we should call this one the beta, this other one gamma. And then finally we'd have the texture. So in terms of colors, we've also got another color for that. And then finally the image textures within each of these tiles. And probably we want like a background color as well that's sufficiently different. Okay, so there's actually a huge amount of geometry in this really simple case, but hey, we can start programming this. Okay, so how do we want to break down this? How do we want to construct this geometry? Everything's going to have to be triangles eventually. In terms of the render, I think it makes more sense to, like, it feels unnecessarily complicated to have to, like for each of these borders to say, like, we're only going to draw, like, the thin, like, rectangles that draw the border. I think it's easy just to, like, draw an entire square that represents the border, then draw a square inside of that to represent the inner thing, and then just everything will be done by drawing squares. So I think it makes sense just to write a procedure for that. I'll draw a rectangle. It would be useful to have a struct. So So let's say we have a rectangle, and what kind of information are we going to want for it? We're going to want its position. That can be a vec2, and then the width and the height. I said vec2 here, but we don't have a type alias for that. Vec2 can just be 2 floats. So this draw rectangle, we'll just take a rectangle, and it's not going to return anything. But it would be good to I think like assign like some kind of buffer that's keeping track of everything that needs to be drawn, and then we can just call it all in a single render draw call. Since we're just wanting this to be simple, I think we could do this with simple color geometry. Like we're not necessarily like no kind of like fancy shaders, but it's just drawing polygons. It's just drawing triangles of a single color. In such a case, yeah, we can create a what do we want to have? I think we just want an array of triangles that can grow. I guess in this game, since the geometry is fixed, like the size of this buffer can be fixed as well. But we can figure the precise size out a bit later. But let's just add this in. It's probably useful to have like the rectangle struct here. If we're going to be storing, just keeping track of all of these triangles to draw, is it worthwhile? Is it even worthwhile creating a data structure that's just a bunch of triangles, or should we immediately be storing what the data we're going to push to the GPU is? I feel like we should be storing the GPU data. So you could create like a vertex buffer. Let's make this unnecessarily large to begin with. But even before that, let's just like, let's have some structure that like captures the unit of thing that we're going to be pushing to the GPU. So let's like make something called a color vertex. Okay, what are our shaders going to need? If this is just a 2D, we're going to need position, that's just 2 floats, and then 3 floats for the color. So you can just specify this as 5. I don't like the idea of specifying this just as 532. Let's give this like some names for things. let's just have like an x that's an f32, the y that's that, and then simply the red, green, blue values. Do we want to be doing stuff with alpha, blending, and opacity? Not yet. We'll do this later if at all. Okay. And then let's say when we're drawing this vertex buffer, we could even make this a variable actually. Color vertex, global color vertex buffer. We'll just make this some sufficiently large number. We'll just do like 1,000. And now say here this is like this game is a rare instance where we can know exactly how many, where the number of triangles drawn each frame is the same, so we can specify the number of them precisely. Update 1,000 to this number. Yeah, this can just be a list of these. Well, update a number to 3 times this number. Okay, to make this undefined. Also, how are we going? How are we going with with downloading the new Zig? It's getting there. Okay. I guess with this color vertex buffer, we also want to know like the current index we're at. Current color vertex buffer index. It's going to be set to 0 initially. Okay, so now if when we're drawing this rectangle, we just want to push to the color vertex buffer the stuff that when we render it, we're going to push to the GPU in a single call. I mean, again, like in some sense, some part of me feels a bit like queasy about just calling the global from here instead of passing in a pointer to it, but yeah, maybe it's alright. We can just do this. Maybe draw rect. I'll say like draw color rect. So the position of the rectangle here, it's so much easier to coordinate everything when you're specifying the center of the rectangle. At least it's the way I think. Here pos represents the center of the rectangle. So, how are we going to draw this? Well, can I like make this bigger? I can zoom in. So yeah, so if we have the pos here and we have the width and the height, we can just draw it as these 2 triangles. So we're going to want vertex maybe like 0, 1, 2, not 0, 1, 1, to draw that, and then we're going to have to push the the same things, 3, 4, and 5 as well. And I guess each of these, the color of all of these will be the same. We're going to need color when we're drawing direct. In terms of type alias, let's just say color is it should be like capital. Color is just it's just 4 bytes. While we're at it, we may as well say debug color. Well, debug color is magenta, and then magenta is equal to the obvious thing, I think everyone knows. Yeah, so we're going to want to push the vertex, color vertex information of this. So let's just write out what these coordinates are. We've got P0, which will be something, and then P1, P2, etc. Do we really want... Like, since all of these coordinates are just going to be different combinations of like left and right things, I think it even makes sense just to write out what those are. So we can just say like left x, or like x left is equal to rectangle dot pos 0 minus 0.5 times the width. The rightmost position is going to be the same thing, but now that we're adding that, then the y is, let's just make it clear. The top of the y is going to be the y coordinate minus the height, and then the y bottom is going to be same thing, but with that. Then we can define the coordinates in terms of these. So we can say point 0 will be maybe just vertex 0. Let's just call these things what they are. Vertex 0 is the color vertex, and I don't want to be like naming what this struct is since it's so tedious, so let's just say function color vertex, which is going to take in an x, y, z, r, G, B. It's probably unnecessary. And then we simply want to return dot x is x, dot y is y, dot r is r, dot g is g, dot v is v. So then we can say this is equal to color vertex. Now we have to do some thinking. So x left, x, y top, then the color dot r, color dot g, color dot v. And then we're gonna want 6 of these. So let's see, from the diagram, if we're just going this way, well, V3 is equal to V1, and V4 is equal to V2. V1 is then in the top right position. And V2 is going to be X left, but then Y bottom. And then V5 is going to be X right, Y bottom. Compute the coordinates of the corners of the rectangle. Compute the color. Yeah, the nodes we will push to the GPU. And then finally, we want to set the what was it? Just we called it a color buffer. Set the color buffer with data. How are we going on the SIG download? Nearly there, but not there yet. Okay, so since we know what this color vertex index is, okay, I'm going to be driven nuts by this long name. So let's just declare I is equal to color vertex buffer index. And then we can say, let's just give these things shorthands. Buffer is a pointer to the color vertex buffer. So that means we want to say buffer I is equal to V0. But really, it'd be better to say buffer I plus 0. I think we could do this with macros, but it's faster to do it by hand. Well, we can. No. Actually, I want to know this. In Vim, there's like a shortcut that allows you to like increase an integer. How do you do this in Emacs? Increase into. You know, that's the macro I want to just move it down. How do you do this? Evil numbers is doing what you need. No, we're not going to stoop that low. Not going to stoop that low. And then finally, we want to do a color vertex buffer index plus equals 5. Okay. And then, yeah, the data will be pushed, and then we can. Something's very wrong. Drawing a rectangle requires 2 triangles, which therefore the number of vertices should be even. The compiler would have caught that error anyway. It would have said, you've defined v5, but you haven't used it. What are you doing? Okay. So that is good. But if we're gonna want to test this out, we're gonna have to set up OpenGL, a vertex buffer a vertex buffer object that describe all of this stuff. But to do that, we're going to need the latest, the latest C compiler. 1 minute 30 remaining. I'm going to be so pissed if, for whatever reason, Zig version 14 doesn't work for this. Like, whoever's maintaining this better make a version that works with Zig version 14. I don't want to have to be using like the dev builds every time. Like Andrew Kelly specifically had a talk where he was just like, you shouldn't be using the dev builds to build software. Mitchell Hashimoto, when you're using Ghosty, you use Zig version 0.13. Like, I'm sick of all of this like partial version. Like, come on, stick to the standard releases, people. Okay. Okay, finally, it's downloaded. So let's not unzip this using the standard Windows unzip file, since that would take an hour. But 7Z is good. And we want to move this to, let's make a new folder called zcurrent. Really, it should be like zcurrent tilde, since we actually want to copy this out, or rather cut it out. Let's rename this to be zcurrent. Let's add this to the path. No, I said, this is like the opposite order. The things which are listed here is the opposite order of what most people want. It's path for your account, then for the entire computer, maybe then just what it is, and Windows is so bad. It's so bad. Okay. Let's get rid of unnecessary stuff. Okay. Okay, so the current version is that. Why did it take so long to get that Windows? But the usual one we're using is that. All right, let's try and build this. No, not Serenum today. I'm gonna have to just port all of my stuff to Linux. Windows is so bad. Zcurrent build. If this doesn't work, I'm gonna be so mad. Come on, are you serious? So yeah, great. The GitHub documentation is incorrect. Wow, quality software. Let's just see what build file we had for like the Sudoku app. I don't know why they just didn't bother writing that out. error, use of undeclared identifier target. That one is on us. Okay, zig out, was it not built there? Okay, we didn't, so it's probably built the library, well maybe. We just didn't ask for it to actually build the exe. So let's do that. Just copy all of this. That should be fine. I mean, I guess it's doing it. If my computer can handle this. Let's, wow, 100 CPU usage. Because, yeah, Microsoft antivirus taking up, what, 25% of my compute. Wow, quality software. Okay, it didn't work anyway. Redeclaration of local constant window. This is something we can at least fix. Presumably. Like, I'm so confused. If you're like providing sample code that builds something, like it shouldn't just produce an error. Why is this not commented out? Like, don't understand. Okay, which version do we want? This version, I guess. Okay, did it work this time? Okay, great. We have a window working. Finally. So let's just start adapting this to sliding puzzle. This. Set up your graphics context here. Attempt to set up OpenGL. And then that would just be our render. Okay, so already now we can start polling, we could start like importing our code and to get keyboards and stuff working. Before doing that, I want to just make sure we can call OpenGL. Once we got to that stage, it will be smooth sailing. We don't need that. Yeah. Okay, I am curious though. Will this build with standard zig? I don't think so, but we'll see. Oh, okay, or maybe it does. All right. Shame that they cut out like the standard. Okay. Kind of surprised. It is working. So yeah, let's now do. Okay, that's working. Let's now do this. Oh no, is it going to be like another bajillion minute download? If so, I guess we'll just start porting the keyboard stuff. But we'll see. No, this will be fine. This will be fine. It was fast with Git the first time. There's no reason to expect it would be slow again. So what, if we go in, we put it in depth, didn't we? Where did we just copy this from? zglfw.zig, where is this? Oh, it's in general dependencies. Okay, make directory zopengl, git clone here. Oh, I see. What's this? If this is requiring a version of Mac, then it is going to have to require one of the latest Zig builds. Okay. This is the readme of anything that. Okay. Either case. So let's do Z OpenGL, then copy some of this in here. We're going to have to go to the build.zig.zon file and add this in. So now we want zOpenGL. Okay. And then let's just namespace this as GL. zOpenGL. Okay, then in the build.zig, we're gonna have to get this. Presumably it's similar. We like similarly get it as a dependency. I guess we can check. Yeah. zglfw, zOpenGL. And how do we use it? Okay, we load like the core pro. Let's just copy it. So we've already got GL, not needed. I guess we can just do this and otherwise fail it if it's not reached. Okay, I can see the utility of having like GL here. Pardon me. Yeah, actually, let's call this a we'll keep it as zOpenGL. Why are we loading 4.0? Like 3.3 should be fine. Clear buffer FV. No, we don't want to be doing that. We can do our own thing. Okay. So let's say we have render. Let's just do GL dot clear color. Let's just make this debug again. And then GL dot swap buffers. I think this is all we need. Zig build run. Oh, legitimate problem. Expected expression found invalid bytes in the zon file. Line 10. What? Oh. String wasn't closed. Okay, so with the standard compiler, I expect this to fail given, or not. Wait, why on earth would you update this to say like bump version if you could compile it with Zig version 13? Okay, I guess it's a, yeah, this is a shock. I am surprised. 25. Oh my god, it's a void. Uh, 12. Get proc address. Should this be glfw? Do I get proc address? Symbol to export must identify a declaration. Oh, I think you miss an A in the dot path. Wait, for which part? Which part? Goto enjoyer. We can. Oh, okay, so it's saying here. Okay. No, it's still not liking it. Okay, maybe in this case we do just follow what is suggested here. Oh, okay, so it's, okay, we're actually, the type of this isn't just some, a constant, it is, well, technically it is like a constant since it's a function pointer, but we honestly have to, we are returning to it like a pointer. Okay. So apparently we can try this one. Unused function parameter name. This is where I kind of want to just look up an example that's working so we can move past all of this stuff. Yeah, for the zglfw, the README for that said there was like examples to be found somewhere. What was it? Yeah, see gamedev samples for more complete usage. Maybe one of these will have a OpenGL example. Just GL. Well, lots of examples, but how many OpenGL examples? Did we not try tfw.get proc address? Let's try copying this one. Wait, how do I where's the button to copy everything? Let's just see if this works. No, it is not. Oh, alright, now this is like a serious issue. Symbol to export must identify declaration. Maybe this is where we need to bump it up from zig 13 to current one. Ah, great. Okay. Let's not bother trying to figure out what was wrong with the previous program, since it will be version 14 soon, and it better work at Zig version 14. And we will get rid of this. Yeah, this is more what I was expecting anyway, to see like a bunch of kind of window hints, as well as to say it's a double buffer. Yeah. Okay. Great. Things are rendering. Let's slightly change this to gl dot what was it, like clear color. Was clearly make sure it's like a debug color, and then we'll save it. Oh, oops. Am I forgetting like a GL command? Guess I must be. if this loads. I can also look up some examples otherwise. Do you like? Why can't I even just like navigate to the web page? This is so broken. Okay, finally. Oh, okay. You have to issue GL clear apparently. So GL.clear, and this would probably be GL.colorbuff a bit. Great, okay. Now we're in a position to save this and move on. So let's call this like a puzzle, sliding puzzle, and can make this slightly larger. Great. So yeah, let's save, before we save this, I should kind of note in the build file that, or at least like the build.zon file, that stuff is being copied in. Let's say, note, also this minimum zig version is not zig 13 anymore, but rather, what is it? Version. Let me say note. The following dependencies have been copied into the source code for the moment. Yeah, when we figure out how to, well, when they work with zig 0.14.0, not yet released, we'll aim to update them to their GitHub links. Now they'll stay local. Okay. But it would be good just to put in the GitHub links of these, where these things are. So zopengl is here. It was zglfw. Yep. Okay. Yeah, let's just clear everything. And yeah, git add, well, git status. Lots of things. Weirdly, the like .exe files have been included that we don't want to add those. So we'll change the git ignore. And then these pdb files. Let's see what else. Any like unnecessary things in here. Yeah, this looks fine. Got debug gflw OpenGL window spawning. Okay. And then I guess we want to push this to GitHub. Move this over here. Okay. Okay. So now we can begin porting over our stuff and start drawing some geometry. So, how will we do this? So I think we want to like copy over the stuff in this test file to the current one. Since we've got one main window, it would be good to assign the window as a global. But what is the type of this window? X number 1. There's no reason why the GI needs to be here anyway. Okay. So let's see. All of this stuff can be done in the kind of init program. But with some additions. Yeah. So let's move all of this to this init program. Here we can say setup OpenGL. All of this kind of stuff. This constant here window we're gonna want to make a global, and then we're gonna want to send the window.destroy to the end of this main. really the first thing you should do is get the stopwatch running, then try and init gfw, or fail. And then for this loop needs to be changed. We can move everything in here to here, and this stuff can be sent to the render file. But we don't want to be debug printing the grid each time now. And okay, and then for this init program, get rid of all of this. We're setting up OpenGL, make it current. Try this or fail. Yeah, this stuff not needed. And our render loop can for the moment just be this. And is the standard input going to currently block our program? So we're calling process input, and I think currently we can, let's just block all of this for the moment. Okay, so current, we also need to adjust the build file so that it is calling main instead of this test file. Okay, zig build run. Look, zig current build run. Line 84 in main. Duplicate struct name. Oh yeah. Alright, doesn't know what a window is, doesn't know what GL is. Okay, we can easily fix the GL one. Okay, if we go to the tab, do that. 268. doesn't know what y bottom is. That should at least clear up those ones. And yeah, otherwise it's just this window. So when we say window is equal to this, we're going to want to store this as a global. Do we have like a window part? No. Window of type something is undefined. Okay, let's say like maybe if I just like incorrectly say what the window type is, it'll tell me what its actual type is. Or not. I guess we should look up what it is. So we're looking for the create function in zglfw. I guess we may still need that in the picture. So we want to go to sliding puzzle, and it was like fn create a window line 747. Depths, sliding puzzle, depths, G, the same thing, right? 7. What's the return type? It's just a pointer to a window. Okay. So what would this be? A pointer to zglfw.window. That'd be fine. Standard has no number named rand. Oh no, this is because I guess in the new standard, in like the standard library for zg14, there's not a rand. Guess we can look up what it is, where it is. So Shiro. Maybe we can do this. The trick didn't work, but declare it to be a type that's clearly false. And then see if the compiler tells us what it should be. Yeah, not. don't have to look this up. Lib standard random. So I guess that's standard.random. Oh, what like try is happening here that we didn't catch? I guess this one here. Oh, is it like the random thing that is? Yeah. Why am I, for catching it, there's no need for it to be trying it. Okay, great. Okay, suddenly, like, the bright purple is a bit too much. So let's do clear color and make this 0.1, 0.1. And then check out what's happening here. Okay. Everything's now in one file, so let's save this again. Got OpenGL window spawning in original code. Okay, so now we can start, we can move over, we can deal with this. Now that we have GFLW, we want to we now want to use GFLW to do keyboard input. Out with the standard input stuff. No need for any of that now. And here is where we want to call like GFLW stuff. So I think we want to say if, or how do we even do key presses in GFLW? It should be in Z. If I do like arrow, will that search it? Maybe like left. Maybe like tab, shift would. Okay, this looks promising. Left shift and right shift. 314 in GFLW. Yeah, okay, here's all of the key presses. So we want to be doing what? So we're going to want something like gfw.key dot what is comma? Not the wrapper. Slash actor, comma. Okay. A, O, and E, presumably. Yeah, all of this stuff there. Okay, and then how do we pick up when this stuff is being pressed? Do we have a like press button anywhere? Or like down, key, is key down? GFW get key. 895. Again, it's returning action, and what's an action? No, I don't want. I don't want it determining for me what it is. I want to know when it's down. That's all. Just tell me when the keyboard is pressed down, please. GLFW determine when key is pressed down. Okay. Well, GFOW doesn't do this? Well, this is wild. Well, this is so wild. Oh gosh, like my respect for GFLW has just plummeted. It's completely plummeted. If this is true, that you can't even just poll whether the key is pressed down or not. Oh, events with GFLW press are omitted for every key press? Okay, so maybe like press is what is what we want. Well, actually, okay, let's just try dealing with this key press. This is massively concerning. Let's just see what this is. Call it action is equal to GFLW dot presumably get key. Or maybe it's like capitalized, get key. Oh, but then it says like window, so is this part? Yeah, it is just get key. So I guess we can call this with regards to the window, maybe. So yeah, so we'll do window. Then what we wanted, glfw dot call it key dot a, and then let's just like see what this is. Dprint action. The action here. Assuming it's compiled. It doesn't currently. So yeah, what's failing? 176. No member named get key. Okay, so is it like is it lowercase get key? Okay. Okay. So this is actually, I don't know why it's called press instead of like held down, but press is actually telling us when the key is actually pressed down. Okay. Terrible naming convention, but it is doing, my respect for GFL has not plummeted. It's doing the thing. Okay, so now we can just simply test each of these things. Let's say if I don't like having like lots of function calls within an if statement, especially when the name of what it is vague. Okay, a down is just this. Comma AOE. We pulled all of those, and now we can just have a bunch of if statements. If a down, then set the up. Well, no, the only reason we were doing like these A and comma presses is because we didn't actually have access to the arrow keys. Now we do. We can just use those. So where are the arrow keys in here? It must be these. Right, left, down, up. Okay, so wait, phone call. I'm gonna have to mute the stream temporarily. And we're back to work. It may still be useful just having like WASD keys here anyway. I think people will expect this. So let's go to this key press struct and we'll just add it in anyway. It's not, this time we don't need any more padding, and we can just say A is visible WAS, what is it there? Yeah, W key, A key, S key, and then the D key. Okay, so now if we go back to this up arrow, WASD, GFW for whether keys are down or not. Likewise here we can say up arrow down, left arrow down, down, arrow down, and then right arrow down. Okay, and then, yeah, is it just like up, left, down, right? And now I want to just set the values of this pack struct accordingly. So we can just say, yeah, if W down key press dot W is equal to true, and then just repeat WASD. Like maybe there's some like smarter way of doing this, but this is a very simple way, so it's fine. I feel like this will make it easy to translate when we push it onto the web anyway. Like these are going to be some, like the WASM will have to query some like JavaScript thing to get from the browser whether these keys are down, and we're going to have to just store. We want to be able to just store them. Just like separate everything out as much as possible, so we can just do everything within the WASM. And then yeah, here we just want. Maybe we can do this with macros in some way. So let's see, here we want to do record macro, delete this, if that, key press dot equals true. No, and I like forgot to, oh no, almost. And now we're saying key press, what was it again? Up arrow, left arrow, down arrow, and right arrow. Okay, this then transfers input events to the byte, the keyboard tracking byte, and now we wanna just check this is working. So okay, so currently all of this is using key press, but what we really want is to store this in another thing called like key down, and then determine ourselves whether there's actually been a key press or not. So we do want key press, but we also want key down. And then we want like key down last frame. This is already like, this is already getting like complicated, but this is kind of the thing that we want to do. Key down last frame. Key state undefined. Okay. So when we're doing the process input, so I think the first thing we want to do is set the key down last frame to the current key down, whatever that is. And let's just, let's set all of these to be 0. To begin with. We then want to update what the key down is, which is all of this stuff. So really, all of this key press should be we want to reset key down. Maybe it would have been faster to attack it. We're then setting key down. And now we want to determine key presses by examining what happened in the last frame and then what happened in the current frame. So now we want to say key press is equal to well, we're going to have to bitcast. We want to just. So the key press is going to happen when it's currently down and not down in the previous frame. So we want to say we want to bitcast. We want to bitcast like a bitcast. Well. Yeah, we want to bitcast the current state of when it's down, and then as a U8, and this with the not of a key down a last frame. Okay. Now this will actually tell us whether there's a key press or not. So then we update the state. If the key presses have happened, do this stuff. And I think here we are. Okay. We actually want to like check WASD2, but before we do that, let's just check that this stuff is getting detected. So let's just say if as U8 bitcast key press is not equal to 0, then deprint key press, and then we may as well print out what it is. Okay. One 17338. Expected bool found action. Oh no, that's right. It like, I forgot. This is okay. I guess here we have to set these to like inequality. What are these possible actions? GFOW once again. Action.press. Okay, that seemed to work. Okay, finally. Hey, okay. I'm pressing things and things are appearing on the screen. Great. Great, so yeah, let's press W, it's true, A, S, D, up arrow, left, down, great. And then if I press other keys, nothing happens. Excellent, okay. Key pressing is working. Let's save this. Many lines of code have been written. So now we want to say got key presses like yeah, detected like yeah, or like did key press processing in, or like detected detected key presses via GRW. Okay, we had like a to do. So we want to move the tile movement with if the up arrow has been pressed or the W key has been pressed. Likewise, if the A key has been pressed, we want to move it down if the S key has been pressed. And then finally, if the D key has been pressed, we want to do that too. Shouldn't we be resetting the tile movement direction to be none at the beginning? Kind of confused. We're not doing that. Yep. When we do animations, we'll also set stuff here, but I think for the moment we can just say tile movement direction is equal to none. Okay, now we're doing this calculate new grid configuration if it changes, finding the empty tile via the crudest way. There has to be a better way to find it than this. We looked up the index function, but it was unnecessarily complicated. Well, it was not that. It was just it applied in a very general case, and this is a very specific case. So yeah, we got the empty tile index and the position. May as well keep that in. Stuff that probably can be simplified and factored, but we'll leave it for now. So I suppose if we detect a tile movement direction, we can try and just print it out then. So let's just do like a very temporary thing here. If tile movement direction is not equal to none, then we want to do the debug print print grid we did last time, debug print. Okay, and this should be like, now like this should enable us to, we'll just, when we press arrow keys, we'll see the grid reflected. So let's say I move the tile, like the other tiles downwards. That moves the space up to the top left. I can move things across. Not liking there's not like an extra line break in this. Where's this? Let's see, it's now there. Move it to the bottom. Move the empty space to the top. Move it around. Yeah, ding, this is working. It's great. Pressing the arrow keys. Look at that. Progress being made. Like just standing back, it's like it's very satisfying to like know that. I don't know how long have we been streaming for now, like 2 hours, to kind of know that within like, I guess we did 2 hours yesterday, but like within 4 hours we can like we're very close to getting like visuals on the screen. Within like 4 hours we can just make like a, I don't know how long this project will take, maybe like 20 hours, but it's, if I really like worked hard like 2 days in a row, I could like spit out this like game in like 2 days, which is like not bad. It's nice to know we have like I couldn't build a chair or like a table in 2 days if I tried. It's just, admittedly I'm not a carpenter, but anyway. Okay, so let's see. I guess no need to save that to Git yet. Okay, so things. I guess now it's the stage where we do need to do like heavy lifting OpenGL stuff. Like now we're going to have to set up like vertex buffers and yeah, just start rendering stuff. So let's actually save this. So we can say yeah, made like debug tile movement. Debug tile movement now linked up with keyboard. Okay. Let's just like push this to GitHub in case there is a power outage, especially with the storms outside. Okay, don't need this. Let's try format stuff. Okay, time to set up the OpenGL. So we have a init program. What's this init grid doing? That's just shuffling it. Honestly, like calling this like init program feels a bit weird. I feel like it would be better to call this like init G. This is initting OpenGL. So let's see init OpenGL. Let's store the setup, the RNG somewhere else. I think we can just set up the RNG in like the init grid. I think I chose setup because I didn't want to spell initialize. Initialize pseudo random number generator. All of that. generate a random shuffle of the integers 0 to tau number minus 1. Okay, let's make sure I didn't mark up anything. In the process of doing all of that. Grid still printing, that's fine. Okay. So I think the grid itself, we can, the grid itself doesn't require any OpenGL stuff, so we can just move this beforehand. Then I guess this is, after we init OpenGL, this is when we're going to have to start compiling shaders and doing all of this stuff. All of this code is like tedious and somewhat the same. I kind of just want to copy existing code to do this. Yeah. Let's do that. OpenGL examples. All of these are on GitHub. What about Codebug? I'm seeing readers, I'm seeing like Z algebra. This looks, what's this? OpenGL study. When was this made? Oh, this is pretty old. I doubt it would work now. What about something in the last year? No. I want to search open. What if we do like OpenGL Z rainbow example, rainbow triangle? But I said search is the side. Oh, maybe this one. Oh, we're not using zglgen. Let's see. Yeah. What's crazy? Yeah, there's like none of it's kind of a rainbow example is a bit vague. Maybe rainbow triangle. Zig, OpenGL, rainbow triangle. No. That's like there's like Odin. I think yeah we will use some code I know. So all of these examples I don't know. And I like just totally in GitHub searching mode. Yeah, no, there's like why is this? We can search GitHub itself. No, absolutely not using Copilot. OpenGL examples. Okay. Lots of examples. What we want, but in Zig. But in Zig. The examples, what we want. Okay, so yeah, let's just like copy the like init code needed for for one of these. Okay. Okay, compile shaders and set up array buffers. This is what we want. Okay. Okay, so let's see. Compile shader error. And then set up array buffers. So let's just use some simple make some simple vertex shaders. Vertex.glsl. Or we can just copy stuff. Copying stuff is fine in most cases. Let's see. Very simple. And if we have the fragment shader, and then I think this should, we can at least try compiling this now. See current build run. Okay, shader compile error global val. What's the shader compile error? Okay, lots of global shader stuff to constants to make. Undeclared identifier, VAO. Vertex buffer 404. size of vertex buffer. Oh, that is a big vertex buffer. I guess for this we can just store the, what was the buffer we called it? The color vertex buffer. Okay, great. The shaders have compiled. Cool. So now let's like start drawing some geometry, I think. Yeah, we're setting up the VOO, binding that. We're going to be modifying the data in, where's the sub buffer data call? Not here yet. Yeah, it's the Strata5 floats. Offset 1, 2, okay. This is what we want. So now what else needs to be done? Sub buffer, it's like sub data. Yeah. Okay, we simply call buffer subdata on the thing we want to send to the GPU, and then call it. Okay. So, okay, so let's call this rectangle drawing function, and just get a rectangle drawing to the picture. I almost want to like split up the render into like do GPU command and something, and then like the actual like usual drawing commands will do. But we can deal with this later. Maybe move to like a separate procedure. But otherwise, let's define a rectangle, and then it's getting kind of dark in here. I wonder if this is too bright. Yeah, let's define a rectangle and then draw it. So we'd say rect1 is equal to, once again, do we have like a function? Let's write a function that constructs a rectangle. rectangle that has pos, that's vec2, w, that's f32, and h, that's f32. Returns a rectangle, and return a rectangle. Pos is pos dot w is w dot hsh. Let's put this, the center at 500, 500 with the width of 100 and 100. And then let's just, it's called draw color, call it draw color rectangle. Draw color rectangle, rect1, and then let's just do debug color to begin with. Oh, I realize if we're like, we're gonna have to convert these bytes into floats, and I don't remember doing that. Yeah, I'm kind of I'm expecting a compile error this time. I mean, it's issuing that as well, but when we draw this thing, we want to be converting these bytes to the colors in this thing to floats. So let's say red is equal to is a float, and we want this to be float from int color dot the first color divided by 255.0. Let's call this R, G, and blue. And then, let's see, all of the references here of color dot, we want to just replace with nothing. Okay. Okay, oh, what? Float from int must have a known result type. How am I not saying it's an F32? Come on. What? What's going on here? Okay, that's not whinging about this anymore. Okay, that whinging is over. Okay, so now, yeah, now we need to deal with this. So, okay, so let's think. So how do we define this? We have this like color buffer vertex that the color vertex buffer. So yeah, if the I mean, this thing's always going to be 0. This is always going to be non-zero, so don't need that. Let's move this like above. Vertex, buffer. What's floats per? Well, floats per vertex is 5. Draw triangles. Well, push color vertex buffer data to GPU. So yeah, how we just want to compute. We just want to put in here the number of rows, which is color vertex buffer index, and then a pointer to the data. So color vertex buffer 0. And why is that there? Draw the character. No, we don't need that. Well, actually, draw the triangles, and then we're drawing I guess it's a kind of peculiarity with OpenGL that you don't specify like the number of triangles, but just the number of vertices. Okay. Let's see if this works. Oh, wow. Okay, great. Oh, come on. Like almost worked and then immediately failed. Why? Did we like exceed some memory thing? We must have. That was short-lived. Short-lived, but it did work. For a tiny bit. Yeah, okay. We must be like spilling memory or something. Yeah, index out of bounds. Okay, so we're like failing to reset the index, which makes sense. I think the very first thing we should do is defer setting the color buffer. What's it called? What's the index code? The color vertex buffer index to 0. Okay. Now it shouldn't like fail. It should just stay here. Great. Okay. Totally resolution dependent at this point, but it's on the screen. Good. So let's save. Let's see. Save this. Got started drawing like drew a square, drew square to the screen. Okay. All right, we are getting there. We are very, very quickly getting to the position where we can draw the geometry that that we did in the illustration. Okay, so now we can just like start drawing a bunch of rectangles to get this grid going. We'll have to worry about like the textures. That's going to be a thing, but we've got colored rectangles working for now. Yeah, textures in OpenGL will be its own thing, yeah, we'll cross that bridge when we come to it. Probably actually before we do like stuff with textures, we can just get like I kind of want to like, given like OpenGL is clearly working enough that we're just like drawing the square, so I'm sure we'll get the texture stuff working. I kind of just want to get the game working with like colored rectangles to begin with, get all the animations and everything for that down. And then once that's done, then we can start messing around with the textures and get those things going. But for the moment, we will we'll push on with this. Okay. So there's a lot of constants and a lot of colors. So let's create a separate file for these colors and just start naming what these things should be. Let's say colors.zig. So we can say constant color is equal to a vector of 4 bytes, and then we can just copy this stuff over, and instead over here we can say debug color is equal to color dot debug. We want to import this color equals @import color.zig. So let's just, we can have, okay, so what are we gonna, this needs to be public anyway. So what are we, like, all of these have to be public. Okay, so we're gonna want like background color. We know all of these are colors anyway, so I don't think there's no need to like append color to them. Yeah, so we have background is something. How do I like can I collapse this panel? Whatever. So yeah, we want background color like the border, the big border color. Kind of just call it, or maybe just border. Well, maybe it's like overall grid border. That works. Then we have like the tile border. And then we have the tile background. Wow, already like lots of colors. And then for the another thing that we're gonna have to do like before if we're like gonna delay doing textures on the tiles into the end, we're gonna wanna like define the tiles to have separate colors. I think we can do this with we can just have a simple function that takes in the byte and then just gives it a number. Like it maybe we can just do like it takes the position and then the X position does something in the red spectrum, the Y position does something in the blue spectrum. We'll get to that. That will be simple. Okay, so let's do like dark gray. This could be like 20, 20, 20, and then kind of want these to be aligned. Then we can do maybe we make the background dark gray, and then for the border we could just make this black. Or like we can copy colors from previous projects. There's nothing that stops us from doing that. So let's see. When we did the butterfly quiz, what kind of, where's the screenshot? Let's just take these colors. These are fine. We're gonna do like colors at the end anyway. If we're not doing textures and other fancy stuff. Where's main.view? Oh, but they were like bit casting them in here. Why? Oh, back when we were using Raylib, macro time delete. Okay. These are now all dead. So yeah, what do we want to make everything initially? Maybe we make the background dark gray too. The tile border black. The tile border, like the grid border black. The tile border. Maybe we make this like a dark gray one, and then for the actual tile background, This is like the gaps between the tiles. We could try this light blue 2. Okay. And we want to make all of these paths. Good. Okay. So let's now. Why did I make this full screen when we're going to be moving back? Let's start drawing rectangles to do this. Okay, so we can make a function called like draw grid geometry. And then okay, now we want to draw this using the colors, which I've already forgotten, but well, they're very close by. So let's just define the rectangles, and then we'll do that first, then what the colors should be. Well, I guess for the tiles, like, we're going to be drawing its position in different places, but I think it should be fine. Oh, now we've got like a bunch of constants to deal with as well, like the tile width and everything, all of these. We'll define them locally and move them around later. So let's do the tile width to start with. Let's make this like 100. Then we can do the like tile border width. Let's make this like 10% is a bit too big. 5% of the tile width. We also want all of these to be floats. Then we want like spacing between the tiles, tile spacing. Let's make this, like 2% of the tile width. Then we're gonna want the like grid border width. And what should this be? Like maybe this should be maybe this should be the 10% of the tile width. And also why it is not aligned. Okay, this is enough to start drawing tiles and stuff. So let's draw everything in the center of the screen, and okay, so if everything's in the center, we can draw the grid border and then the grid background only like the only thing we need to calculate those are the sizes of them. But let's first of all just declare where the center is. So the center will be vec2, which will be what, 500 to begin with now, before we like, I was gonna say before we like make the resolution of the screen like changeable, but now I'm thinking if the overall target of this is YZM, and if we're also going to be porting this to the Serenum where the screenworks is fixed, it feels like it's unnecessary programming to like make it resolution independent and all of that. So we'll deal with this for now. Keeping in mind that it is a magic number. So then we can do like grid width is equal to, it's going to equal to the number of tiles times the tile width, or rather the grid dimension times the tile width plus the grid dimension plus 1 times the tile spacing. But then we also need to like add in there's a decision to be had about when we're drawing the border around the tile, whether that begins from the outside of the tile and goes outwards, or begins and goes inwards. I'm kind of inclined to say it should go inwards, just because it makes like these calculations simpler and less complicated. But I mean, it's not really that much more complicated either. But given we're going to eventually be doing textures on it, it makes sense to like make the border go outwards. Okay, so then we're going to have to add in 2 times the grid dimension times the tile border width. Okay, and that's the grid width, and then or rather this is like the inner grid width in some sense. And then we could say like the outer grid width is equal to the inner grid width plus 2 times the grid border width. Okay, and now I've got this, we can start drawing some rectangles, or constructing them finally. So we can say outer grid rectangle is equal to the center, the outer grid width, and then the outer grid width. I think this is like in my head now enough that we don't need the picture. The inner grid is the same, but just with outer replaced with inner. And then this is already like enough to start drawing some things and make sure we're not like totally off. So now let's draw the colored rectangles for these. And we should say like to do calculate, or rather like construct tile rectangles. But otherwise, we can draw the outer grid rectangle. And we want to be drawing here the tile border color. And we want to draw the inner grid rectangle with the tile. When I said this is like tile background, I think it's better to call it grid background. Grid background. Okay, let's try and compile this and get it going. Oops. Emacs, stop it, stop it. This keyboard is so bad. Zoom out. I want you to finally. Oh goodness. Okay, 306. Void. Unable to load color.zig, file not found. Oh, we called it colors. Use of undeclared identifier tile border. Oh, it should be color.business. Function shadows declaration of color from, oh, yeah, we should just really call these colors. Color dot, what am I doing? Color dot, replace with colors dot. Expected semicolon after decoration. Easily fixed with an equal sign. Okay, great. Okay, so this isn't in the clearly got a square, like a thing with a border. This isn't in the center of the canvas, which is what I want though. Yeah, given we said we were drawing this at like coordinate 500, 500, why is it appearing here? GFW. I'm kind of surprised it's showing on the screen at all, because at no stage did we normalize what these coordinates were. So if anything, it should have been drawing it like off the side of the screen. Okay, where's like draw color rectangle? Yeah, we're just like drawing the positions here immediately, which is not what we want. normalize assuming the screen is 100 by 100. Is this the right place to be normalizing this stuff? No, it feels like this stuff should be normalized in the vertex buffer, not here. Absolutely not here. Oh, here it is. It's being divided by 1,000. Okay. Let's just say like the position is equal to a pos 0, 1, and then the raw position is this, and then the zglfw normalized position is equal to this DL position is the normalized one. And then we want, we'll see if OpenGL has a whinge about wanting to multiply the raw position by, hang on, it's 1,000 by 1,000, so we want to we first want to move it to between 0 and 1, and then scale up to 0 and 2, and then move it back to 1. Let's see if this compiles. It did, but okay. We've lost it. It's being drawn off the screen now. Okay, I guess what did we have before? We can. I'm confused as to why that's booting it off the screen. Yeah, like we want to let's call it like unit square pos is equal to like for this thing, and then the actual position we want is 2 times great, this is what we want. Everything is centered, it's working. So back to the render, back to the draw grid geometry. Okay, so yeah, so we've done the border. We now just want to do the internal squares inside, and then draw the tiles. So we need to calculate the positions of all of these things. let's create a struct to hold what these rectangles are. Since these rectangles are the dimensions of these are comp time constants, we can just set everything up. We know ahead of time how much memory these will take. So let's say grid, grid tile rectangles. Be a fixed array of size I thought it was like tile number, yeah, tile number, and these are rectangles, undefined. Let's say top left tile position. We're gonna have to calculate this. So this will be what is this? The center minus there's like non-trivial calculations happening. Is this going to change? Is the calculation going to change depending on whether the dimension is odd or even? I feel like it shouldn't, but then maybe it seems like it would. No, it shouldn't. We can kind of use like the grid. In some sense, it just should be like half. You can either like do it internally, or we can just like use the previous. I think the easier thing to use is like the outer grid width, or the inner grid width calculation, and we simply go to the left border of the inner grid, which is given by half of the inner grid width, and then just add on one of the spacing, one of the border, and then half of the tile width. Yeah, we'll do that. Top left tile pos x is equal to center the x coordinate of the center minus half of the inner grid width plus tile spacing plus a tile border width plus half of the tile width. Okay. And since currently stuff is symmetrical, the top left tile pos y should just equal the top left tile pos x. Okay. So then we can say tile pos is equal to top left top was x, top left, top was y. And now we just want to have like a for loop where we fill up the grid tile rectangles with this thing. So now we can say for, just keep it like a simple double loop across the grid dimension varying in I and j. We want to say that the grid tile rectangles I times the grid dimension plus j is equal to, well, let's just define what the rect actually is. Tile rect is rectangle let's see, tile pos. Tile pos. Oh, there's going to be like, it's going to be U-size conversions and stuff. Ooh, maybe. This is now annoying. Okay, let's say, so the pos x is going to be why am I saying this is like a we don't need this. So the x position is going to be the top left tile position plus, we're going to have to cast float from int the I here. We're going to be adding, we're going to have to add for each I one of the spacings and almost like one of everything. Tile spacing, 2 of the tile border width, and then the tile width itself. And the pos y calculation is basically the same, except it's now a j, in which case we can factor this out. Oh, we've got like the i's and the i's and the j's that are around the wrong way. Maybe you want this to be j and this one to be I. And now, yeah, so now the tile rectangle is going to be pos x, pos y, and then just the tile width in both these directions. And then we're setting j times the grid dimension plus I to be tile rect. We've set all of those, so then we want to draw the tiles. Then we say for in the grid tile rectangles, for every rect that's there, we simply want to draw color rectangle, and let's draw it with the color that we specified, which was I guess we didn't specify it. This is where we want to call like the function that will determine what it is. give each tile a unique color. For the moment, it's just debug. Okay. Let's see how. Let's see if we got the geometry right or not. Okay. Unused local constant 325. (332) cannot assign to constant. Oh yeah. Ah, wait. It worked first time. Excellent. Well, almost first time, except here the colors that we're choosing for I'm not distinguishing like the tile border from the tile itself. Yeah, this is like a because this thing. So why is it called tile border? Shouldn't this be called grid border? And oh, in order to like okay, we're gonna have to construct a like for each of these like rectangles, we also, since these are the tiles, we want to draw like the tile border. So we actually want to tile border rect is equal to rectangle rect.pos so let's say tile border rect width is equal to the tile border width plus 2 times the tile 2 times the tile border width. It's 2 times the tile width. So then we want to draw the colored rectangle of the tile border rect with the tile border color. Then we want to draw the color rectangle inside of that. And it's not getting the colors. Why? 3, 4, 6. Oh. Didn't namespace it. Okay, now now we're getting a geometry problem. And also, like, where's the black at the tile border? It's been totally obfuscated. Oh. We shouldn't be multiplying the tile width by 2. Clearly. Okay, this is much better. This is what I wanted. Okay, so now we can. Okay, it's kind of difficult to see the black tile border, so we might make the background of this. Okay, well we already have a background color here, so let's go to the gl dot clear color. Yeah, we're gonna have to convert this like color to the like an OpenGL color. Yeah, this was a bit silly. What is it? Background is dark gray 2. Dark gray 2 is stuff. Let's just make it not slightly lighter and not purple. Okay. Okay. So there is a slight complication here, which is that we don't actually want to draw all of these, because one of these is meant to be a gap. It's meant to be like a hole. So if we move it over to this side. Tile rec. So actually the number should be one less. And then, we're gonna have to. Actually, we'll keep the number of things in here, and we simply will skip over drawing it when it comes to this function down here. So I think, in fact, here what we want to do is, for instead of the grid tile rectangles, we want to be iterating over like the grid itself. Who cares about this? We'll do it later with this full script. Yeah, if tile is equal to 0, continue. Otherwise, rect is equal to the grid tile rectangles I, then the rest should hold. Okay. Aha, there's a hole, and aha, we can move things. We can move things around. Great. And we're not even doing this with Rail. This is just with in pure OpenGL with zglfw, and the internet has helped out a lot too. But, so already I can see that some of these key presses are incorrect. Like when I'm pressing left and right here, this is moving correctly, but when I press like down, it's going in the wrong direction. I think this is due to, this may be due to like an OpenGL direction issue. I think the easiest way to fix this will be determining a color based on like the grid value. But even so, like we may as well save this now. The easiest way to verify this is just looking at our debug values. What am I talking about? Okay, so let's see, when we move the hole to the top left, oh yeah, see the hole is reflected down here at the bottom. So certainly moving it across works, but it's just the orientations are around the wrong way. So why? Oh, maybe I was assuming like the top left coordinate, the origin was up here, but maybe actually the origin is down here. Okay. This should be easy enough to fix. But let's just save it so that, okay, we've done a lot, we might as well save it. Got grid rendering, got grid tiles with debug colors rendering. I may as well push it. Okay, so we want to get we do want to give each tile a unique color, but maybe before that, we may as well do that now. So yeah, how should we do this? We could say constant let's call it posx again. Oh, that won't like it. Call it xval is equal to tile remainder grid dimension, and then the yval is equal to that, and then we'll just make the color based on this. The color is equal to what should we make this? 20 times, why don't we do like 20 plus 20 times xval. We'll make like the green constant, maybe like 90, and then 30 plus 20 times yval, 255. And we'll call this tile color, and then instead of colors.debug, we just want this to be the tile color. Okay. Cool. These colors are not differentiated enough for my liking, so let's change those a bit. Could even go with 40, these. Almost. Some of these are very similar in color as well. Too many of these blues are the same. Let's adjust the green values as well. Let's adjust the green with like Y value. Some of these are now looking too light. Maybe we'll reduce the amount of green. No, it didn't look bad at some stage. It looks like a total retro color scheme. No, let's we had something good and then we mucked it up. Let's try this one again. I don't know, yeah, this isn't, I think this is almost enough for testing. We just want to make it like slightly more blue, I think. Yeah, I think this is fine. Yeah. This is not at all a like color blindness friendly palette, but this is fine. This is good enough for testing. It's fine. Okay. Okay, so now we want to also get the direction around the correct way. So it's to do with the position of these. Maybe we can even just change this in the shader. I think that's the easiest way. I don't want to change any of the math, we'll just change it in the shader. Okay, let's change this to like vec for normalized is equal to this. And then the GL position is oh no, this stuff is going to be affecting like the final coordinates, which if we overwrite them is fine. Oh, I still feel a bit icky about this. So now we want to have make the inverted normalized.x negative normalized. Why can I not alt tab this? Hello. Normalized.y. And now we want to say the inverted 0, 1. Okay. Let's try and compile this. Great, and now the colors. Okay, let's verify this with our debug output that this is correct. Yeah. Tiles are moving in the correct direction and the holes are matching up. not bad for an evening of work. At least I think. Beginner programmers cannot do this without using the latest JavaScript library in ChatGPT. And we used none. Never will. We didn't use any LLMs today, but that's also because we're using a sensible programming language that we know a lot about. We know some about. I don't know. I think I know. I know some. I have some degree of confidence in the Zig language. I mean, I know all of the standard library, probably most of it, but I can write course. I can read the standard library most of the time, unless there's any V-table stuff. Okay. So yeah, let's add in this. Let's say what am I doing? Git commit Gabe tiles Gabe tiles colors, inverted Y pause to get to make to make grid lineup. Okay. So yeah, let's push this to GitHub, and I mean, yeah, it's satisfying to just where is it? Zig out. I said zig out. Like, fill it up, please. Oh, well. Let's just remove everything from zig out. Let's also just clear the cache as well, and we'll do like a fresh clean build. Zig current build run. Okay. But yeah, satisfying to go from thing in my head to scrappy drawing to thing that you can press buttons with and it works. This isn't. It's satisfying. Like, I haven't changed like the size of these tiles as well. Like, the gap in the border width was total estimation, and like I don't think I want to change it. Like I'm happy with it. Happy with these proportions. These tiles are a bit sharp, admittedly, but we're not going to be doing smooth geometry stuff. This is, again, we're porting this to the Serenum, so we're just going to keep it simple. And WASM, we're going to keep it simple. We figure stuff out. So yeah, thanks everyone who, we don't need to remember those changes. Thanks to everyone who came around, hung out today. I don't want to save that. And yeah, I hope everyone has a good rest of the day. Not sure when I'm going to stream next, hopefully a bit tomorrow. But there's just a huge amount of admin coming up that that's going to consume a lot of my time, so we'll see. The next week, lots of paperwork, lots of Microsoft Word documents. Anyway, I'll get through it. I always do. Have a good one, everyone. Bye.